We've talked a lot about how to visualize or organize data in charts and graphs and tables, but now we want to start talking about some of the things we can do mathematically to better understand our data. And the first thing we need to talk about is what we call measures of central tendency, which are different ways that we've come up with to kind of describe the middle of the data. You might think there's really only one way to describe the middle, but in fact, we've come up with several because sometimes, depending on our data set, there's a better way to describe the middle than maybe another way that we would have used in a different situation. So the first one that you hear about all the time is the mean. And a lot of times we say average, but technically when we're talking about average, we're actually talking about the mean or arithmetic mean. And if we have a data set, first of all, let's say here, mean. If we have a data set, something like 2, 4, 7, 7, we'll just pick a really simple data set. The mean is what we get when we add up all the data points and then divide by the number of data points that we have. We usually denote the mean with the Greek symbol mu. And like I said, the way we calculate it is by taking the sum of all data points and dividing that by the total number of data points. So in the case of our data set here, we would add up all of the data points to get the numerator. So we would say 2 plus 4 plus 7 plus 7, and then we would divide that by the number of data points we have. We have 1, 2, 3, 4 data points, so we would divide that by 4. And the result there is 2 plus 4 is 6, plus 7 is 13, plus 7 is 20. So we would end up with 20 over 4, or 5. So the mean of this data set is 5. Now the fancier way to write this formula is like so. We use summation notation, the sigma symbol, and we say I equals 1 to n of x sub I, and we divide that by n. Now this looks really fancy, but basically all we're saying is we're pretending that x is a data point in our series. When we say I equals 1 down here at the bottom, what we're saying is start with the first term. If we had I equals 2, it would mean start with the second term. So if x just represents a generic term in our data set or a generic data point, x sub 1 is the first point in the data set. X sub 2 is the second point, x sub 3 is the third point, and on until the end of the data set. So we're saying start with the first term when we say I equals 1. And then the summation notation, the sigma symbol, means add up all the data points. Start with the first data point and keep adding and adding and adding until you get to the nth data point, which is the last data point. So this numerator here just means add up all the points, find the sum of all the data points, which is what we already had here in plain English. And then it says divide that by the total number of data points, n. So this is the technical way to write the formula for mean. This is just the intuitive way, but no matter how you remember it, you always just do the same thing. You add up all the data points in the numerator, you divide by the total number of data points you have, and then you simplify that fraction as much as you can, and that is your mean. One way to intuitively understand the mean is as a balancing point of the data. And what we mean is that the distance of all of the points in our data set from the mean will be equal on the left and right of the mean. So for example, let's say here we know our mean is 5. We'll use the same data set we did before. So the mean is 5. Think of this as a balancing point, like this is a seesaw and it's balancing perfectly on this fulcrum in the center. The mean of the data set is 5, so it's right at the center. If we imagine here a number line where we have 4, 3, 2, and we could keep going 1, 0 all the way on, or on this side, 6, 7, 8, like so. Our data points are 2, 4, 7, and 7. So let's go ahead and say here 2, 4, 7, and 7. If we imagine the mean extending up like this, our mean is at 5. The distance that we have from the mean to this data point here is 1 unit. From 5 to 4, that's 1 unit. And from 5 all the way down to 2, well, 5 minus 2 is 3. So that distance is 3 units. So we have a total distance of our data to the left of the mean from the mean of 4 units. On the right-hand side, this point is at 7. The mean is 5. 7 minus 5 is 2. So the distance here is 2 units. The distance here, since this point is 7, is also 2 units. So if we add up our total on the right-hand side, 2 plus 2 is 4. And we can see that we also have 4 units of distance on the right-hand side. So the mean is just the value that balances the amount of distance on the left-hand side with the amount of distance on the right-hand side. It makes them equal to each other. The median of a data set, the median is another measure of central tendency. It's a different way to measure the center of a data set. We'll again use the set 2, 4, 7, 7. So let's just go ahead and write that over here, 2, 4, 7, 7. In order to find the median, we always want to follow the same process every time. We take all of the values in our data set and we line them up in a row from smallest to largest. We've already got that done here, but sometimes our data isn't in order. It'll be all mixed around. It needs to be from smallest to largest. Once we have it in that form, then all we're doing to find the median is looking for the middle number. So in this case, what we would do is we would cross out the first number on the left, cross out the first number on the right, and we would keep going until we find the center. Now here, once we cross out those two numbers, we're just left with these two numbers here. If you get to a point where you only have 2 numbers left in the middle, then what you want to do is then find the mean of these 2 numbers in order to get the median. And so again, finding the mean is just adding up all the data points, in this case just the 4 and the 7, so 4 plus 7, and then you only have 2 data points there, so you divide by 2. 4 plus 7 is 11, 11 over 2, or that's the same as 5.5. So the median in this case would be 5.5. Keep in mind that if we had many more data points, for example, let's say we had 1, 1, and then another 2, and let's say over here we had another 7, and then an 8, and then a 9, we would have started crossing out the endpoints here and worked our way in like this and crossed out the 2 and the 7, and then this 2 and this 7, and ended up with just the 4 and the 7. Take the mean, and then this value here gives you the median. This is what happens when we have an even number of data points in our set. So we can see we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points in this set. The reason it always works out that way when you have an even number is because you cross out an even number on the left-hand side. We were able to cross out 4. With the same number on the right-hand side, you cross out 4. And you're always still left with 2 data points in the middle of the set that you then have to find the mean of in order to get the median. But sometimes we'll have a data set like 1, 2, 3, 4, 5. Let's say this is our data set. We have in this set an odd number of data points, not an even number. In that case, when we start crossing things out, so the first value on the left with the first value on the right, then the next one with the next one, we're just left with one number. And then it's really easy because we just take that one number and that becomes our median. So when you have an odd number of data points, just line everything up in order from smallest to largest value, and then cross out values till you get to the center number, and that is your median. If you have an even number of data points, line them up from smallest to largest value, cross out data points on the left and the right in equal number until you get to what will be left, which is just 2 numbers in the center, then find their mean, and that will give you the median. The last measure of central tendency, and this is probably the easiest one, is the mode. This is just another way to measure the tendency of the data. And mode is simple because it's just the number that occurs in our data set most often. So, for example, if we have the original data set here, 2, 4, 7, 7, So 2, 4, 7, 7. The number 7 occurs in our data set more often than any other number. So 2 occurs once, 4 occurs once, and 7 occurs twice. So because 7 is the number that occurs the most, our mode for this data set is 7. It doesn't matter if we add more data points to this. Let's say, for example, instead of our set being 2, 4, 7, 7, it was 1, 2, 4, 7, 7, 8. 7 is still the number that occurs most often in the set, so the mode is still 7. In this data set up here that we used for the median, 1, 1, 2, 2, 4, 7, 7, 7, 8, 9, 7 would also be the mode of that data set because 7 occurs 3 times, whereas all of the other values only occur once or twice. 1 occurs twice, 2 occurs twice, 4 only occurs once, 8 and 9 both only occur once, 7 occurs 3 times, more than any other value in the set, so the mode there is also 7. If you have a data set like this, let's say 1, 1, 2, 3, 7, 7, there are 2 ways you could describe the mode here. You know that 2 and 3 are definitely not the mode because they only occur 1 time each, where 1 and 7 both occur twice. So then the question becomes, which is the mode? Is it 1? Is it 7? Is it both? Is it neither? Well, there's really 2 acceptable ways to answer it. You can either say that this set has no mode because there's no clear winner. 7 does not occur more than 1. 1 does not occur more than 7. There's no single number that occurs more than every other number in the set. And so we just say the set does not have a mode. It doesn't have a clear winner. And that would be okay. Or sometimes people will say that this set is bimodal. So they'll say bimodal. Remember that bi means 2. So bimodal means 2 modes. And you would say, of course, 2 modes because 1 occurs twice, 7 occurs twice. They're tied for the lead, so it's kind of like having 2 modes, and sometimes it's helpful to describe the set this way to indicate that there are 2 numbers that emerge as the mode. Now keep in mind that if we had, for example, the set 1, 1, 2, 2, 3, 3, 7, 7, we wouldn't say that this is quad modal. We wouldn't say that the mode is 1 and 2 and 3 and 7. All of the values in the set occur an equal number of times, so there's no real winner at all. We don't really say anything beyond bimodal, that there are 3 modes or 4 modes or more. This is just a special case where we may choose to say, you know what, there are 2 values that tied for the win, so we'll call the set bimodal. But for the most part, if there's no clear winner, we say that the set has no mode. We really want any mode that we mention to be the true clear winner of the set, like the 7 was in this set.